So hello everyone. In this video I would like to talk to you about the signs of the trigonometric ratios in the different quadrants of the coordinate of the Cartesian coordinate system. Now this is your Cartesian coordinate system, and let me see, pen. Dynamics of. Okay. So this is the Cartesian coordinate system. And this is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. And you know that in the first quadrant, x is positive, y is negative. So if I were to write the x and y's as pairs, I would write x is positive and y is positive as well. Here you can see that the x's are positive, y's are positive. Here the x's are negative and the y's are positive. In the third quadrant, x's are negative, y's are negative. In the fourth quadrant, x's are positive, y's are negative. And so based on this, you can see how the different trigonometric ratios are going to behave. Because basically, when you say that, for example, sine theta, no matter where theta is located in this coordinate system, it's going to be the opposite side divided by the hypotenuse. And let me draw this here for you to show you what I mean by that. For example, let's say this is a coordinate system and you have this angle right here. And then, so based on this is your angle, and this is your y, and this would be your x from here to here, right? So this would be your y. So if this is theta, this angle, then sine theta here would be the opposite side divided by the hypotenuse. So the opposite side would be basically y divided by the hypotenuse. The hypotenuse in this case, let's say it's 1. So it's basically your only just y. So now your y is a positive value, and your trigonometric ratio of this angle is just in the first quadrant, so y is a positive value. Now if theta was in the second quadrant, something like this angle, then you would have basically something like this. Let's say you have this angle over here. If you had this angle, then you have an obtuse angle, and we said that in case of obtuse angles, you basically have to write sine theta, for example, or sine beta. Sine beta is equal to, beta is not very much like beta. So we said that sine beta is equal to, we said that you have to divide your y divided by your, if I'm not wrong on that, your y divided by, let me see, divided by r, right? Right. So you have to write y divided by r. So now this is your r. Basically your r is, let me see. Let's say this is the center, and if this is your y, and you take a point over here, for example, any point P, and this is x comma y, and now the distance between this point P and O is basically your r here. So you could write this as y divided by the absolute value of OP. So the absolute value of OP is your r, and then this would be basically r, the radius of the circle around this Cartesian coordinate system. So in this case as well, r is basically the absolute value of of the distance between 2 points. So it's basically a positive value. It doesn't matter where it is. And your y is basically, in this case, it's y is greater than 0, because basically this is your y value. So in this case, you can see that your angle is, you can see that sine beta is greater than 0. In this case, in the previous case, you can see that sine theta is greater than 0. Is greater than 0. Now, if you come to the third quadrant around here, if you had an angle like this, right? And this is again your y value, and this is your x value, and this is your p, let's say. So this is again, this is your p, x comma y, and this is your y value. Now in this case, for example, sine let's say alpha, if this is alpha, sine alpha would be again y divided by OP, and then again you get OP is in any case is positive, but your y value in this case is negative. So it means that you're going to get a negative value. So in this case, sine alpha is less than 0. So you can see that sine in this case is negative, and so on and so forth. So you can investigate the different trigonometric ratios for the different, you can investigate the sign for the different trigonometric ratios around this Cartesian system. You can investigate it for sine, cos, and tan for in the first, second, third, and fourth quadrant, and then you would get something like this. Basically, in the first quadrant, all of the trigonometric ratios are, all of them are greater than 0. In the second quadrant, sine theta is greater than 0, and all the other ones are less than 0. Because as you can see here, your y values are positive. In this case, all the values, all the x and y values are positive. So you, in any case, you end up with a positive value. In this case, your y values are positive, the x's are negative, and so as an example, I could tell you, for example, your sine. We already investigated sine in the second quadrant, and sine was positive. But for example, let's see if you had an angle over here. If you had an angle over here and you were to find cos of beta, cos beta would be x divided by r, or x divided by OP. But in this case, x would be a negative value divided by OP, which is a positive value, so you would end up with a negative value. And so that's how it basically works. And in the third quadrant, the tan of theta is a positive value, all the other values are negative. And in the fourth quadrant, the cos of theta is a positive value, all the other values are basically negative. So there is a in some mathematics books you see the abbreviation all students take calculus, and in order to ASTC, and you can basically remember it by, you can memorize it as all students take calculus, like this. And when I was in India, studying mathematics as part of a course, and I had a teacher. He used to tell me all students take coffee. So, but it's basically the same thing, calculus or coffee. They both starts with a C. So that's basically the sign of trigonometric ratios in different quadrants of the Cartesian system. And that's basically it for this video. I'll see you in the next video.